So you guys know, silence your phones, but I don't care. If your phone rings, take it. Hope it's important. PASS has a lot to offer. I've been a PASS member for over a decade. I've spoken at SQL Saturdays and at user groups from Europe to Asia to here. And I'm very grateful to the PASS organization for their professionalism and their volunteers and their platform to speak and get the word out. They're a great organization. I hope you guys take advantage of everything that they do. No one gets really paid, by the way. So like I'm standing here, I don't get paid to be here. Like everyone volunteered their time to be here. So it's amazing to me how many volunteer hours go into an event like this. There's session evaluations at the end. And this is me. I've been a Microsoft MVP since 2011, which feels like yesterday, but it's almost 2018. I've spoken at PASS Summit several times in the past, including the Business Analytics Conference. And I've written a book called Developing Azure Solutions, which will hit its second edition by the end of the year. I'm finishing up the last technical editing for, it might as well be a whole new book. They change Azure so much, like, that's all new. Just since I've got your attention, just for a minute, I do 3 things in San Diego. One of them is irrelevant to you, and 2 of them might be relevant to you. The one thing I do is I'm the co-chairperson of the San Diego Software Architecture Group, and we meet every month, and it's a great meeting. I love that meeting, but if you're not in San Diego, it's useless to you. The second thing is I'm the founder and chairperson of the San Diego Tech Immersion Group, and that group is a technical book club that meets monthly and reads the same book together. And what we do is we stream our meetings on YouTube. So the reason why I mention that to you is starting in January, we are going to start a 3 or 4 month R track where we're going to read in our book together that we've got a link up on sdtig.com. And we're going to stream those sessions for free on the 4th Tuesday of every month. So if you would like to learn R with me and hang online, you're welcome to do that. And then the third thing I do is I'm host of a monthly San Diego meeting called Nerd Beer, where we go to a happy hour. We pick a new bar in downtown San Diego every month, and I give 3 topics of general conversation. I say things like, let's talk about a new framework that got released, or let's talk about some drama in the local business community, or let's talk about a recent Azure problem that got highlighted, or whatever, right? I give 3 topics of conversation because I know that developers and data professionals are often somewhat introverted. So I say, look, if you're at a bar and you see a bunch of nerds and you don't know what to talk about one of these 3 things. So I'm pretty proud of Nerd Beer. They do it in Oklahoma, and they do it in San Diego, and they're starting it in LA. And maybe, if you think it's a good idea, you should start it in your city. Just a place to, it's really low effort. I like to have beer, right? I like to talk with friends. I like to make new friends. Sometimes making new friends in our community is a little bit hard, so I made that venue to do it. So this session is about things that I have noticed that great developers have in common. And first, before we begin, I just want to tell you I am humbled at the turnout to this session. It almost makes me cry. So I'm grateful that you spent the 75 minutes with me. Very grateful, and I hope it's worth your time. This session is not about SQL performance. There are many sessions about that. There's 20 years of sessions about that. That's not what this is about. This session is not a SQL internal session. You can talk to Kaylin Delaney or Adam Mechanic, or the internal people are very good, and they have been doing it a long time, and they're some of my heroes, but this is not about SQL internals. This is not a SQL language best practices session. There are books and books written about that. Although there will be code, and we will talk about performance, and we will talk about some internals. But this discussion is about the personal habits and characteristics and thought patterns that I have noticed that great SQL developers have in common, and great developers in general. So it's not just about SQL. It might just be might apply to all developers. Some of it, most of it will apply to all developers. if I were creating a session to only benefit me, I would do like a Dave Letterman top 10 list where I would count down to the number one thing. And then you'd stay to the end, hoping to hear the number one thing. But I didn't write this session. Remember, some of you were in the room. Pass asked me to speak. I didn't submit this session. And so I don't care about keeping you gripped to your seats for 75 minutes. I care about being effective. And so I put these in reverse order. I'm going to tell you the top 3 things right now. The top 3 things right at the very beginning I'm going to tell you. And if your kid calls with an emergency or your husband says that he needs to know how to work the microwave or to, whatever, you can leave and do that after the first 10 or 15 minutes. You're not going to hurt my feelings. Hopefully, you find enough value in the first 3 points that you stay and listen to the remaining points, because I think there's a lot of value there. So without further ado, the number one thing you can do to distinguish yourself between being an average developer and a great developer is to use source control. I don't know what happened to my slide. Did it die? Where is it? Hang on. Yeah, this is what happens. Boom. Use source control. Is it hidden or something? Why did that not come up? No, I don't know what happened. There it is. Use source control. OK. Yeah, right. That's right. So source control is like a document management database for your code. And typically, when we talk to non-SQL developers, they use source control uniformly everywhere. But when we talk to SQL developers, we often see some gaps in their use of source control. And when I go consulting, I see these gaps a lot, very commonly. So if you are using source control, let me be the very first person to applaud you for that and thank you for that, because you are a leg up above a lot of developers that are out there. The main reason why SQL developers don't use source control is because it's difficult. It's difficult for 2 reasons. The first is our SQL databases have state in them. And that state, the records in the tables, make source control a little more complicated, right? Because the data is actually valuable, right? So we often think about backing up the data. But what we're not doing when we don't put our code in source control, and by code, I mean our tables, our stored procedures, our functions, and our views, and our user-defined types, and our security, which often fails to go into source control, our security. The benefit we get when we put those things in source control is, 1, we get a history of how the project has evolved over time. So when people say, who made that change, that question is answerable when we're using source control. So the reason I can tell when you're not using source control, because if I look at your stored procedures, I see comments in them where whole sections of code are commented out. And when I ask, hey, why is this stored procedure green? Why is everything green in here? They say, we might need that one day, right? That's why it's green, right? But that means that they're not relying on source control, because if they were, they would have faith in their source control system to bring that code back if they ever needed it. They wouldn't need to just put comments in it. Or another thing that I see a lot, is I see comments telling me what the code is doing all over, right? And I don't need to read those comments. I can read the code. I know what it's doing, right? And what happens when we have those comments in stored procedures is it makes the stored procedure itself very difficult to read, because it's a lot of horizontal scrolling back and forth, right? So not only are we polluting the code, but we're actually making changing the code very difficult, right? So there are a lot of things we can do to use source control. You can use, right now, Visual Studio with TFS for, you probably own both those things, probably. You can integrate TFS with Git. You can use Redgate source control. You can use another product called Apex SQL for source control. You can even do it by hand if you want to. If you wanted to script all of your objects out to files, put it in some file system, and by hand check that into Git, that is better than nothing. So the number one thing, if you learn nothing from this lecture, but just please use source control, you will have a leg up. I'm going to show you, by the way, I'm not paid by Redgate, not paid by them. So I'm going to show you a Redgate tool, but it could be any tool. If I right-click and I click on New Database, I can say, my pass Summit DB, right? And I click OK. And then from here, I can just right-click, and I can link this database to source control. I use Git. So there's a local Git repository on my disk, and I can say, please just link that. And it links that database to source control. And now I can right-click on that database, and I can say, please get latest. You watched me create this database. You watched me pull everything and apply the changes out of source control. And you watched all these tables come down automatically. I can make a brand new table if I want to. It's probably easier to do that in code. Create table, test, pass table. Call one int, right? That's really important. Execute that. If I right-click and I say commit changes to source control, the changes, sometimes it's a little laggy. Right-click, commit. How come you can't see that? Oh, was I in the wrong database? That's why. I thought I did my pass Summit DB. There we go. Create it, right-click, commit. And there's the change. Click that, put in a comment into source control. You've already got a leg up on everyone. I didn't make this up, by the way. One of the reasons why I know this is important is because of an experience I had. I had a development leader come to me and say, Ike, my team keeps missing deadlines. They keep putting bugs into production. They keep making mistakes. And I think I need to fire one or two of them. And I said, OK, that's a big decision. And he said, but I need to know who. And I said, you don't know who? And he's like, no. He's like, I've got these developers that work for me, and I don't know how to tell the average developers from the great developers. How would I tell the difference between the two? Because I can't write code. So I want you to tell me who is average and great. And I'm like, whoa, that's a big responsibility. And it kind of made me think, like, I know a lot of development leaders who can't write code. How do they tell the difference between their average developers and the great developers? So I started asking everyone. I'll ask you guys. Anybody will tell me. I asked a lot of people, and I got a lot of different answers. I heard things like, well, if they don't write bugs. If they don't write bugs, they're great, right? But what was funny about that is, like, when I go back in my recollection and think about the great developers, so many of them write bugs. They write bugs all the time. And I think the reason why they write bugs is because they're not afraid to go into the hard thing, right? They're not afraid to go into that 5,000-line stored procedure and start ripping it apart, right? There's a lot of bugs when you start ripping apart a 5,000-line stored procedure, right? But the thought of the 5,000-line stored procedure was so obnoxious to them, right, just piercing them, that they weren't going to let it stand when they looked at it, right? So I don't think you could go, but they don't write bugs. IBM decided their best developers, they were going to compensate them by lines of code they wrote, right? That's a terrible thing, right? So I talked to my business partner, Scott Reed, one of the best developers I've ever met, and I said, Scott, if you were non-technical, how would you distinguish between an average developer and a great developer? And you know what he told me? He said, I could almost certainly pinpoint them by the amount of times they check into source control per day. And I said, you think you could? And he's like, I have noticed that the great developers check in every 10 minutes, every 15 minutes, every half hour. And the very worst developers check in every 2 days, every 5 days, or not at all. And I said, as soon as he said that, it clicked with me. And I started noticing the same habit. And now when I pair with other people and I watch how quick they check in, why are they checking in so fast? Why are they checking in so frequently? Because they're experimenting. Yeah, and they're like, did that work? Did that work? Did that work? And if any of their experiments failed, they roll back because they rely on their source control system to get them back to where they were before, right? So using source control allows us to take risks, and that risk-taking will make us better developers because the source control will catch us when we fall. Yep. OK. And there's a lot of other reasons, but I think I beat that to death. Are you with me? We're all going to use source control? That's awesome. So at Crafting Bytes, we have this poster in our conference room. That's Elf, and he's testing a Jack-in-the-Box. And he's surprised every time the test runs. But we say, test twice, then test again. This is habit number 2. We thought, before I named my company Crafting Bytes, I actually thought I was going to name it Test Double, because I thought that it was a distinguishing characteristic between my software studio and everybody else. We tested everything all the time. We believed in automated tests, user acceptance tests. If you have a new testing framework and you love it, I would love to hear about it, because we will use every testing framework that comes our way. And the reason why I didn't name it Test Double was because it was already taken. The domain was already taken. The name was already taken. I was like, ah. So Crafting Bytes, I think we landed on a really good one. But we love testing. And we put this on our slide deck, and we talk about it. And we think our #1 job is to craft great software, and our #2 job is to test and verify that we did it. So testing has a lot of benefits, but one of the main benefits testing has is it preserves intent. So when we look at software development, like right now, if I go into a project and somebody says, you only allow us to roll back sales at the first 60 days. And I'm like, yeah, I can clearly see that in the code. Do not allow a rollback of a sale past 60 days. And they're like, why? That right? Why? Why did you write that? I'm like, I don't know why I wrote that. You told me to, probably. They're like, well, we want to know why and when and what was wrapped around that logic, right? And the intent behind why we write code is what's often lost. That's why often we see swathes of green commented text in the stored procedures, because we're trying to preserve why in there. But we don't need to write comments in stored procedures to preserve why. We can do that through writing some type of testing. And the testing could be any type of testing you want to write. I'm a big promoter of. So if you say, I only want to write tests in C#, fine, write all the tests in C#. If you say, I only want to write tests in SQL because that's the only language I know, fine, let's write tests in SQL. So there's a different way of writing tests that I'll talk about in just one second. But look, there's a product out here that's free that you can use called T-SQL-T. And you can start using T-SQL-T today. And it's a testing framework inside Transact SQL that you can drop in any of the databases. And this T-SQL-T schema, this schema is where they put all of their objects in. And so right here in this database, that's just my example database, if I create a new query, I can just do T-SQL-T, that's their schema, dot run all. It's just a stored procedure that will run every single test in a testing schema that I've registered with it. So I could have 500 tests or 5 tests. It will run all of my tests. And when I run it, it runs through all the tests and say, hey, one fails. I know my resolution isn't the greatest, but if you look over here, it says this last one right here, test ready for experimentation of 2 particles, it failed. This test failed. Now, before I talk about debugging this test, I want to instill in you the power of this, okay? At some point, some developer at some time wrote a test. And they named that test something important. They said, test the experiment for 2 particles. That's what they named it. And they put it in the source control. They checked it in. They might have done it like 3 years ago, right? And then I get asked to do a change in the code. And so I change a stored procedure, I change a stored procedure, I change a stored procedure, and then I run all of my tests. And oop, a failure, right? What did that failure help me do? That test failed 3 years after it was written. It told me a whole bunch of things. What was it? What did that failure tell me? I broke something that was important enough somebody wrote a test about it, right? That's one thing. What else did it tell me? Maybe the intent changed. Yeah, it could be that that test is outdated, but now I've got something I can go back and verify with the stakeholders. Hey, did you mean for this logic over here to change when you told me to do my thing? Yep. What else did it tell me? No, it didn't tell me that because I won't check in. Something like, I check in to my local repo often, but I won't merge to the main repo unless all the tests pass. That's just polite. So it told me what failed. It not only told me there was a failure, but it told me what actually failed. And I have bad news for you about stored procedures. They're late bound, which means we don't get to know that they failed until they run. So that means something has to run them. So if you're not running your stored procedures in test, the user is going to run those stored procedures, and that bug is going to get elevated all the way to production, right? Nobody wants that, not you and not the user, right? So these tests, at minimum, they run it to make sure that it can run. And OK, so look, if I'm debugging this and I say, oh, this test ready for experiment if 2 particles, and I right-click here and I modify it, this is my test here. Let me get rid of this properties window. Every good test does 3 things: arrange, act, and assert. Arrange is, let me arrange everything so that the experiment is ready to go. Act is, let me run the experiment. And I'm saying this for all code, not just because this happens to have experiment in the title. And 3, assert. Assert that I understand the results of the experiment and that I approved them. So you'll notice that also in the test that it's OK to use spaces, because we're only really going to use the stored procedure in the test runner. So you can make it verbose. This is not real code, right? This is test code. So it's OK to name the test stored procedures really, really long so that we preserve what we were doing here. And then finally, I see, oh, look, it added 2 particles. It called is experiment ready. So look what I can do. This is part of Redgate SQL prompt. I can script object as alter. One of the reasons why SQL developers don't like to write tests is because code navigation is painful. But we're going to, with a few other tools, we can make code navigation less painful. One thing it will do is just let me peek at it right here, right? I can look in the script, and I can just do a quick peek, right? But I can right-click, and I can say script object as alter, go into what I'm testing and say, oh, it's a boundary error. That's common. But if I say greater than or equal to because of the boundary error, remember it was testing 2 particles, but it was doing a greater than, I execute, I fix the bug, I run all, and now they all pass, right? So even with just this little short demo, I hope you're catching on to the power of testing. Writing good tests, even if you're the only developer on the team, you're all by yourself, is you loving yourself, your future self. You're saying, future self, I love you, I respect you, and I'm going to make your job easier when things break. That's what you're doing. And then when your future self hits the bug, you can say, past self, you're so good to me. Why did you do? You're so good. Thank you so much. OK. So a lot of benefits here that you can go in the slide deck on your own. But again, my goal is I want you to understand that testing is valuable. And even if you don't test using T-SQL-T, and even if you don't test using C#, testing is your responsibility. It is not QA's responsibility. It is not some low-level developer's responsibility. You wrote the code. You have an obligation to make sure that code works. So take that obligation seriously. Now, I already told you about T-SQL-T, and you probably already know about in-unit. That's the C# test runner for unit testing. But at Crafting Bytes, 2 technologies that you might not be using or that are not as popular in the Microsoft world as they are in the JavaScript world and the Python world and the Java world is called Cucumber and Gherkin. So the .NET implementation of that is called SpecFlow. And what it does is it allows you to write down business cases in plain English and then wrap tests around those business cases. So that's called behavioral-driven development. And the reason why we like it is because we can have our tests written by the stakeholder. So a non-technical person can say something very clearly. I'll give you an example of a Cucumber test that we just wrote last month. It said, if a user is logged on and they are 16 years old, force them to have a parent sign their application. Does that sound like English to you? Right? Does that sound like something somebody would come to you and say? Right? So that is the actual text of a SpecFlow test that we wrote. And then that test gets folded into our source control and run every single time we release. So we release code every day on that project, and every day that test runs. And if that test ever breaks, we know we broke critical business logic. So that helps us preserve intent. It helps us pay it forward to our future selves when we break something, right? Okay, so and then the other thing that we love to test data with is something called approval tests. Approval test is a graphical way of approving a large amount of data if it changes out from under us. Okay. One final note about testing, and then I'll move on. And that is, I have noticed that great SQL teams don't use production data in development. And I've said this many times, and every time I say it, people look at me like I just am like the worst person. And they always ask the same question, so I'm going to preempt that question right now. They say, sometimes we only see bugs in production, and we need the production data to find those bugs, right? So that's why we put the production data in development so that we can code against it so that the production bugs get found. They tell me that every time. Have you heard that before? So there's a difference between bug identification and bug correction. And so I'm not saying that developers don't need access to production data. You do need access to production data. What I'm saying is you should never be writing against production data. That's a difference. And if you need access to production data, that can be a temporary thing. We can have a production bug, right? We have a canary environment where we do bug identification in the canary environment. And then when we see what caused the bug, we thread that use case back into our development environment, and we write a test against it to make sure that that test fails. So we're going to write the bad data. We're going to thread it back into development. We're going to write a failing test. Then we're going to correct that bug with a passing test. That's called red-green refactor. The reason why we're doing that is because production data changes, doesn't it? Production data changes all the time. So if we keep refreshing development with production data, our testing is useless because the test results will change out from under us every time we run the test, right? So in order for our testing to stabilize, we have to be coding against a small subset of development data. That's the only way to effectively test data. There's other things you could do. You could use Rhino mocks or mocking framework or something like that. But even Rhino mocks are stabilizing the development data that you're writing tests against. The reason why I'm telling you this is because a small subset of development data is portable, easier to manage, easier to back up, easier to restore. But most importantly, it makes your testing stabilized so that you can run your tests repeatedly and always get the same results. T-SQL-T, by the way, has something to make your tests repeatable. It automatically rolls back every test. So remember, every test has arrange, act, assert. So you arrange, you act, you assert, and then T-SQL-T automatically rolls it back so that you can run the test again and again and again and again and not have the data change out from under you. They call that, when data changes out from under you, they call that testing the weather. Yeah, because it's hard to test daily weather, right? Okay. So habit 3. Is this good so far? Yeah. Oh, thank you. I'm glad. So habit 3, remember I told you the first 3 are the most important, and then the rest I'm going to fill in some stuff. So this is another poster that we have on our wall. I don't know if you noticed, but on the testing was ELF. This is Alec Baldwin and Glengarry Glen Ross, and this YouTube clip is about Alec Baldwin talking about closing to salespeople. And he says, ABC, always be closing, right? And if you've never seen that clip, I'm not going to play it for you today because it's 7.5 minutes long, but you should go watch it. Because in my opinion, Alec Baldwin says to these kind of lazy, inadequate salespeople that their value is closing a deal. That's their full value. And I tell the developers that work for me that your value is shipping software. And anything that gets in the way of shipping, we should re-examine. So your job, people pay us. They don't pay us to write software. I can write software all day. Nobody will pay me to do that. They pay me to ship a completed product, right? They pay to use the software that I've written, right? So habit number 3, always be shipping. Again, this is on our conference room wall. So if I interview you, you say, hey, Ike, write a piece of software for me, right? And you tell me what you want. right? You say, I want software that does this, and I write it down. I like take great notes. I'm a great note taker. Note, right? And then I go write it, right? And then I hand it back to you, right? The first thing I almost always hear is, that's not what I said. That what you wrote, that isn't what I said, right? I'm like, well, we made mock-ups. Yeah, but that's not what I meant when I did that, right? And the reason why is because when that person gave us requirements, there were a whole lot of assumptions made, right? They assumed that they communicated clearly what was in their head. They assumed that I heard what they said. They assumed that I relayed that back to my team correctly, right? So you see assumption, 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 and there's a gap between what was really in their head and the assumptions that went down the pipe before it got created, right? So the way we tackle that is we ship as early and as often as possible. On some of our projects, we ship multiple times a day, meaning we ship code to production used by users multiple times a day. Flickr wrote a blog post. You guys know Flickr, the photo sharing app? They wrote a blog post, and in that blog post they said, we ship 10 times a day into production. And our deployment mechanism is so good that we know we can ship directly into production because our tests are so good. They wrote this big, long blog post. And it really angered Facebook and Netflix. And they said, those guys ship 10 times a day. We can ship more than that. And so they started keeping track and competing with each other. And now, like Netflix says, we shipped so often, we can't count how many times code goes into production. That's how often we ship, right? And they call that continuous deployment. And we can do that, but take a wild guess what continuous deployment requires. Testing and source control, right? So if you do the first two things well, it will increase your ability to ship more frequently. You'll be shipping all the time. And when you ship all the time, you will shorten the time span between assumption and delivery. And that will mean that when I'm wrong about what I heard, it's a cheaper mistake for me to correct. I'm still going to make mistakes. I'm still going to assume incorrectly, right? But I'm making that a cheaper mistake when that happens. So, okay. So in order to always be shipping, you have to automate, automate, automate. And that means that we're going to fold tests into our deployment process, which means if we wrote testing for the project, it's going to run every single time before we actually deploy. It also means that someone should get really good at scripting. You guys know Grant Fritchie? Do you guys know Grant? Yep. He was on stage a few years ago, and he said something that stuck with me. He said, you've got two choices and only two choices. You can either get really, really good at mundane, repetitive tasks, or you can get good at scripting. So I'm like, oh, that's awesome. He's absolutely right. So deployment is a mundane, repetitive task. And for a lot of average SQL developers, they might do it by hand. The worst SQL developers will create tables in production. They'll write the code out and run it, right, in production. That's an awful practice, and we should not do that. The average SQL developers will manually do some type of comparison tool. They will use some compare, and they'll see the differences, and they'll create a script, and they'll deploy that script out. But the great SQL developers will do it automatically. They will have some type of automatic deployment process that they rely on. It might be gated. They might test. They might say, do it automatically, but right before you click play, let me see the script to make sure you did it okay. That's a gated deploy, perfectly acceptable. That's like, lets us sleep at night, right? But they believe in automatic deployment. They script all day long, and they get it done. If somebody says, sometimes I have to change production directly, that is almost always because the deployment pipeline is either unreliable or too slow. So if we can work on shrinking the time it takes to deploy automatically, we will rely more upon it, and then when we need to get a hot fix through, we can still use our deployment pipeline to get the hot fix through. That was the top 3. I've got some more, but I hope that was worth it. So habit number 4, I don't do often enough, but it's question, reevaluate, and act. So I've noticed I'll give you a story about where I did this very poorly. So .NET Framework 1.1 was released, and it did not handle nulls very well in .NET Framework 1.1. And so I made a decision, and as a SQL developer, I said, no nulls in the database, because it makes .NET crash all the time. And I said, no nulls, no nulls. Just use defaults, no nulls. Everywhere, no nulls, right? And then .NET 2.0 introduced nullable types. And 2 years after that, I told a development team, don't put nulls in the database, use defaults. And they said, why? And I said, oh, yeah, why? Oh, it's because it makes .NET crash. And they're like, what, like 1.1? Who cares, right? Like, we're now moved on way beyond that now, right? So it really made me realize, like, I have a tendency, and I think we all do, where we make decisions and then we forget what kind of sequence of events led us to make that decision, and then we don't reevaluate previous decisions. And the reason why I know that that's a problem with developers is because when I'm in a room and I pitch an idea and I said, we tried that, I hear this all the time, we tried that before, 5 years ago, and it failed, right? But maybe something's changed in 5 years. That means a failure 5 years ago. It might have been a good idea 5 years ago, but we had some environmental issues that made it fail that we can now reevaluate to go forward. So question your derived answers, get new information, evaluate, and just like you can't watch The Sixth Sense again without remembering your new information, apply that. So habit number 5, this is another poster that we put on the Crafting Bytes offices. And by the way, if you do stay around to the end and you give me your business card, I will draw 10 people, and I will email you and ask you what poster you want, and I will send one of these posters to you so you can put them on your wall. So just give me your card at the end, and I'll email you and let you know. Only 10, though, because they're kind of expensive. So this poster is on the wall. Do you guys recognize this image, what movie that's from? The Shining. Yeah, that's right. So that's the Shining maze, and we say, cut through the maze, always do the simplest thing that will possibly work. We are not rewarded for the complexity of our code. Examples of complexity would be like recursion, right? Recursion is very hard to debug, very hard to thread in our minds sometimes. Another example of complexity would be like nested subqueries, right? It's syntactically possible, but it doesn't mean we should do it, right? Another example of complexity would be needless triggers, right? Yes, there's a device in SQL that allows us to use triggers. That doesn't mean we should do it. It will probably complicate the solution, right? So we love simplicity. Simple things are maintainable and debuggable and changeable. Small things are also those 3 things. So we like small and simple wherever we can. So a year ago, somebody came to me and my business partner and said, we have $75,000, which, by the way, we're a small shop. $75,000 is a lot of money to us. So they said, we have $75,000, and we want you to write the software that does this. And they gave us a spec, kind of already written. And we looked through the spec, and we looked through the spec, and we looked through the spec, and we said, do you mind if we watch you work? Like, we want to watch what you do. And so we watched them work for like 16 hours. We watched them work. And at the end of it, my partner and I met and said, I think they want us to rewrite Excel. Like, I'm pretty sure this is what Excel does. And so maybe what they're frustrated with is that they're sharing data through Excel, but we can centralize the data and still let Excel do its job. So we spent an additional 8 hours, created a data model for them that automatically loaded data into it for them, all without interference, and then just an Excel query that let them pull and use it. And they thought we were magic. They thought they were prepared to give us $75,000. Their final bill was like $6,000. And the reason why is because we believe in doing the simplest thing that'll possibly work. Our job is not to write code. Our job is to ship value. And if that can be done, I work with a guy named Llewellyn Falco. He was a 2009 Agilist of the Year. I've learned a lot from Llewellyn. And Llewellyn said, I prefer to delete code rather than write it. I think deleting code is the greatest thing ever. And he would brag about it on Twitter all the time. He'll still brag about it. He'll say, deleted 15,000 lines of code today. Because he understands that writing code is, it's an asset, just like buying a boat. You love the boat goes around the lake, everybody loves it, but nobody likes flushing the engine. Nobody likes cleaning the brakes. Nobody likes maintaining the engine, right? So it's the same with code. Everybody wants to write it, but nobody wants to maintain it, right? And so when we delete code, we're creating a smaller footprint of things that we have to maintain. So in stored procedures, when I don't see commented out code, I often see a flag switching it, right? And there's a flag in there, and then an if, and then like 50, 100, 200 lines of code under that if. And I say, what's that flag do? And they say, well, once in a while, they want to not see the gross on all these queries. So you see repeated logic. You see the query with the gross in it, and you see the query without the gross. And then when I run Profiler, guess what? They always want to see the gross, right? So I go back and I say, turns out nobody cares about the non-gross version of that query. They always want to see their gross profit. So I'm going to delete this code. Wait, we might need it, right? No, we're going to simplify this thing for you. We're going to make it easier to maintain and easier to change. And we're going to improve the speed at which we deliver. OK, habit 6. I have had great experiences writing software. I've had very memorable experiences writing software. One time when I was a brand new developer, I was like 24 years old, and NASDAQ called me and 6 people into one room to rewrite one aspect of their software that was an emergency. And they said, don't leave till it's done. And we slept and ate in that room for 6 weeks together. And we never left until it was finished. And I have never had more fun writing code than I did those 6 weeks. Those people totally focused on one job, completely engaged until that job was finished, and then finishing it and delivering it was something I try to recreate with my team as often as I possibly can. And so,
do you lock them in a room?
No, they don't like it when I do that. They're all, everyone's married and has a dog to feed. But they do love coming, I hope, knock on wood, I think they love coming to work. So this is what's called a mob. And we do mob programming. We have a mob station at Crafting Bytes. And we have these really large TVs that are set up with one keyboard and one mouse. And one person is on that keyboard and mouse. And everybody else is talking about the code on the screen and the tests that are being written. So that is, usually the mob has 3 or 4 people. And what we're doing when we mob, we don't mob all our software. We don't mob everything. We mob for very specific reasons. And those reasons are in this slide right here. We mob to teach, meaning I know something, and I'm tired of being the one to write it all the time. So I'm going to write it with you. So I'm not going to drive. I'm going to put somebody else driving, and I'm going to talk them through it, or 2 or 3 people through it. We mob to demonstrate keystrokes and tooling. We mob to learn domain. Often we'll have like a customer come in, and they'll mob with us. And they'll tell us domain knowledge that we wouldn't otherwise have. So we mob to learn requirements, like flesh out things that we're doing. You'd be surprised how many business stakeholders like to see their product mature. They like to watch it. You'd be surprised. One time I was mobbing at a customer, and a random guy walked up and said, my turn on the keyboard. And he went on the keyboard, and we stood around while this random guy I'd never seen before, $500 million company. The guy left after an hour and a half. I said, who is that? They said, the CEO. We're so used to mobbing, and he knows that if something's important to him, he can come join the mob. That CEO has an engineering degree, hadn't coded since college, but knew that when we mobbed, we would tell him the keystrokes and tell him what to write. And certainly it slowed down a little bit, right? It doesn't speed up when somebody like that is on the keyboard, right? It slows down. But think of the user trust that's created there. Think of the things we learned from the CEO's mouth, like as he's talking and typing, right? A lot of knowledge was exchanged, and that's the best thing about mobbing. You don't mob to make the project go faster. You mob to make sure that you're coding the right thing at the right time, right?
We dealt with mobbing with very remote
Yep, and we do that too. We'll do it over Join Me or GoToMeeting or Google Hangouts or, yep. We use a combination of HipChat, and we will absolutely mob. The problem with not being in the same room, we found, is that you're prone to distraction. So anything we can do to pull them back into distraction. So the way mobbing works, by the way, and again, we're not mobbing because it makes us faster. We're mobbing because we have a higher tendency of writing the right thing the first time rather than rewriting it. So what you do is you have a guy called the driver, and he or she sits at the keyboard and talks, and then you have navigators, and the primary navigator will be directing the driver, and the other people will generally be talking about coding strategy. So it turns out that it's very difficult to think of three things at once, right? It's difficult to think about keystrokes and to think about the tactics of what code to physically write and think about how that code fits into the overall project as a whole, right? Those three things are different, and if you let three different people have those jobs, you'll get a higher quality code. The other thing that mobbing does, look, raise your hand if you've never taken a shortcut in writing code. Oh. No one raises their hand, not me, not you, right? When you mob, you have a higher tendency of even the most junior developer right out of college saying, are you sure we should be doing that? Like, that doesn't seem right. Are you sure we should be doing that? And that question alone will snap us back to reality and make us question our practices and make sure that our, hey, Ike, I noticed you didn't write a test there. Oh, yeah, you're right. I should write a test. So this mob, by the way, is at one of our customers. That's not Crafting Bytes, because our mobbing station's in a tiny conference room, but this is one of our customers' mobs like this. And this customer started with 6 developers. They're up to 35 developers, and they fired their entire QA department. They took their best QA developers, and they made them full developers. They took their average QA developers, and they made them do YouTube videos and write documentation. And they took their worst QA developers, and they released them. But they got rid of the entire QA because mobbing, testing, source control, and continuous delivery dropped their bug rate that much. OK, so yep, it's a team sport. Typically what we want to do is focus on one task, complete it, test it, verify it, check it in, and if we can, deploy it, and then work on the next item. You know what is a terrible job? And I've had this job before, being a silo developer, where you're all by yourself and there's nobody else with you. And you're the only person that knows the app, and you can never go on vacation, and you can never get sick. And if they do a deployment, you better have your phone on you. That is a terrible job. It is much more fun when we're writing as a team and we can rely on our teammates. OK. How much time do I have? 3:15? 4? I'm good till half hour or so? All right. So habit number 7 is fight dependencies. So I get a tendency of being pretty preachy about this topic, but a dependency means that if I change one thing, it affects something else, right? And dependencies are necessary in coding. But the problem with dependencies would be dependencies that we can't control, meaning I change something here, and other people that are not on my team yell at me for changing it, right? That's an external dependency. And the best example ever created in the history of computer science of an external dependency is a transact SQL statement. So you create a schema, a Rembrandt of a schema with 5 different tables, 30 different tables, 100 different tables, and you immediately write a select. Select this from this, join that, join that. You are creating a dependency, which means if you change that schema, that query stops working, right? We know this. We've seen this. And it doesn't stop working at compile time. It stops working at runtime. When we hit F5 or when it runs in our code, that select stops working, right? OK. That is fine to do if you are writing the query and you are writing the schema. Do that as much as you want, as long as you know that when you change the schema, you've got to change the query. The problem is if you have a CFO with Excel and direct access to the database, no way. We cannot do that anymore, right? Because now that CFO is going to create Excel data models to close the month or close the year or do their finances, and they're going to hit your database directly. And that means that if you change your schema, they can't close the year, and now you can't change your application because of an external dependency. So that is what we're fighting. With just a deep ferocity, we're fighting anything that stops us from changing. So remember earlier we talked about those assumptions that we make. If I'm going to hear business requirements, and those business requirements are going to change, right? Here, I'll show you. It's this graph. Can you see that graph at the bottom? So that graph has two different axes. One axis is the amount of time it takes me to write code, and that's the vertical axis. And the horizontal axis is the amount of time since the project began. So if you ask me on day one, Ike, change some code, and I change it, and I change it, and I change it, and you're like, good, that's good. Okay, change some more, I change it, that's good. Okay, change some more, I change it, that's good, right? You think I'm a great developer. Every single time I ask Ike to change something, he changes it, and it goes to production, and he's great, right? But 6 months down the line, a year down the line, 3 years down the line, you ask me to change something, and it takes longer and longer and longer for me to do that change, right? Until eventually that arrow going straight up is representing change lock, which is you ask me for a change, and I say, no, I can't change it, right? That's change lock. That is the death of every application. And when an application gets to change lock, we often hear things like, we should rewrite this terrible app. Like, this app's awful. Like, somebody get in here and rewrite it. This is, oh, who wrote that mess? We don't even want to change it anymore. Hey, I'm going to go change that server. No, don't change that server procedure. It's a house of cards. You change that server procedure, 15 things break, the users hate us, don't change it, just live with it, right? I once had a customer come to me and say, Ike, we want you to write 30 triggers for us. And I said, what? No, I'm not going to do that. And they said, we want you to write those 30 triggers because we don't have access to the source code anymore. The developer we fired took it with him, right? And so we want some business logic implemented, and we want to do it through triggers. And I said, well, first of all, you just described a criminal issue, right? And I think that one strongly worded letter by an attorney will get that source code right back to us pretty quickly, right? Because nobody likes prison, particularly nerds really don't like prison. But that is an example of change lock. So what dependencies do when they're external to us is they lock our assumptions in as the truth, right? That's what they do. So all dependencies are bad, but the worst kind are the kind we don't control. So what does that mean? It means, and this is the kind of the controversial thing about external dependencies. It means that if somebody comes to me and asks me for direct access to a table, let's say it's an ETL developer. Let's say somebody's writing an SSIS package in a different team, and they want to pull data out of my database. At the minimum, I'm going to make them pull from a view and not a table. So I'm never going to give any external developer access to the tables themselves because I realize they're going to start writing queries against it, and that's going to lock me so that I can't change, right? So I'm going to create views. I'm going to create stored procedures. I'll create functions at minimum. In my opinion, fighting dependencies is one of the biggest reasons to use ORMs, and to preferably, I won't even give them access to the database. I'll give them access to the data through a web API that I'll write. And then they'll hit the web API. Now that API that I've written in C# is now my boundary. So that gives me the freedom to change my schema and changing the API that I control without even informing the other side developer that anything changed, right? I use the API as my contract, and now it lets me change anything internally that I want. And the reason, let me finish this one thought about dependencies. One of the biggest things we can do to improve SQL performance is either normalize or denormalize. Like, those joins are expensive. And so I can tell when you're hitting changelog by only looking at a database. If I look in a database and I see one table with 300 columns and half of them are empty, like they're all nulls in there, that tells me you've hit changelog, right? Hey, why don't you delete these columns you wrote in 2007 that nobody's using? Because things break and we never know what breaks when we do that, right? Or if I say, hey, I've noticed that your database has 300 tables, but when I do profiler, only about 30 of them are being used. Can I remove these ones that all start with Z? Or, no, oh, no, don't do that, because when we do that, the data warehouse guys all scream at us because they're pulling those tables, right? So that tells me that we don't have a great handle on our external dependencies. It also tells me we don't have great testing. You had a question?
What is ORM?
Oh, object relational mapper, like Entity Framework, or my favorite one is Dapper, which, believe it or not, there's a session on Dapper I saw on the schedule, and I was super excited to see that because I love it. It's like my favorite ORM I've ever used. It's written by the Stack Overflow guys. So if you want to learn more about ORMs, go to that Dapper session. I think it's after this one or tomorrow.
It's like this time, next time slide.
Yeah, I'm going to go. If I can, I'm going to go. OK, any other questions? Dapper. Yep. Dapper, yeah. I shouldn't say that. I mean, I do like Entity Framework, but it's a little heavy. Dapper is very lightweight.
Tomorrow, too.
But, oh, tomorrow. Cool, thanks. OK. So we fight dependencies, and that includes avoiding 3-part and 4-part object names. So a 3-part object name is database.schema.object, and a 4-part object name is servername.database.dbo.table name. Those should be removed everywhere you see them, right? Because what you do when you use a 3-part name is you're locking 2 databases together so that they have to change together, right? And if one database gets overloaded and we say that database needs its own server, we're going to move that one to Azure, or we're going to do something with that, those 2 databases, now that you're using 3-part names, have to migrate together. They're locked together. That's a great example of an external dependency. Why even have 2 databases if you're going to lock them together through these names, right? And 4-part names are even worse, right? 4-part name, you're locking 2 servers together. The great example of that, one of my customers said, we want to upgrade to SQL 2016, but we can't until we test every stored procedure on that other server that uses a 4-part name, right? Oh, my goodness. Is that on your team? No, that's a different team. They're not even in this country, right? I've got to test now with developers who aren't in this country to make sure this server gets upgraded. That is a great example of an external dependency, right? So we fight against them. We remove them where we can. But if you are going to use 4-part names, at least use a DNS alias so that we can change the server name and then change the DNS entry and then change it, right? Things like that. But always be thinking, anytime somebody external asks you for data access, you should eye them suspiciously. Like, how can I get around this? This is a bad idea. OK. Yeah?
So by that token, if you do have to use connections between 2 different databases, would it then be better to use a 4-part so that you can at least always have that option instead of refactoring code to just use the C?
No, I prefer to use an enterprise data architecture diagram. So I prefer to use like SSIS and like pipe the data into an operational data store and get all the data out of a central database that we have clear delineation from, right? This idea, by the way, is not new. This is the whole idea behind microservices. Microservices says this top bullet, one application, one database. And make sure they go through the front door. In a microservices architecture, it's considered very rude to even ask for access to a data layer, right? Always go through the front door. OK. Habit 8. I've noticed that great developers know when and where to error handle. Error handling is like spicing food. Not too much, not too little, but there's a right amount that's just perfect. And in error handling, what we try to do is we flag, fix, or fail. We recognize that an error is coming in, and we decide to, at minimum, audit it. An error happened, and we're going to log it someplace. We're going to fix it if we can, and if we can't, we're going to fail gracefully. So we're going to code for resiliency. We're going to do connection retries and so forth. You can download these slides. I'll get to the good part in just a second. OK. Yeah. Yep.
The slide before this, you were talking about fully qualified names.
Yep.
I was under the impression that removing fully
Well, I would definitely use schema in object name, but I don't think, no, you don't have to ever referencing a server by its name. Yeah.
Like a three-part with the database schema and.
No. You can remove the database name. Yeah, for sure. Yep. But I mean, using schema and object name is probably just good practice, not relying on the default. OK. So love your tools. My partner, Scott, interviews people, and he counts in his head how many times they use the mouse. I don't know why, but he just thinks that people who use the mouse all the time don't love the tool enough. So there's a few things about SSMS that are just kind of nice that help with code navigation. One's Control-KC. What does that do? Isn't that great? And Control-KU to uncomment, right? And just like a few of these shortcuts are kind of neat. Like if I do select star from, and let me pick the right database. We'll just do sales.customers, right? And if I look back here, and I'm just showing you a few things that you might not know that it does. Did you know, first of all, I bet you did know this, that if I go into that database and I pick out a column from sales.customers, you know that I can just drop a column in here, right? Right? You know that. Did you know I can take the column folder and drop them all in there? Isn't that neat? OK. So another thing that often happens is we come in here and we kind of do a little bit of code formatting here, right? So we've got these three columns, and we just alias it. Customers C, and then we join orders O on C.custid equals O.custid, right? And then let me kill this thing right here, boop. And then we run that, and we get what? Oh, invalid object. Oh, it's sales orders. Let's try that. So we run that, and what do we get? Ambiguous column name, right? This guy. And it says we might have 2 or 3 ambiguous column names, right? So what we can do is hit the Shift and Alt key and do object selection and alias them all at once. So block selection. Did you guys know you could do that? So you'll also notice that my taskbar here is at the top, and it's red. That red tells me I'm in production. If I'm at a different server and I want to change that connection to tell me that I'm in development, I can go to Change Connection, Options, select the color, and make that maybe some type of like bright green, right? Click OK. Click Connect, and now that's green. That's development, and that's red. That's production, right? So a couple of these things that SSMS can do is really, really powerful. And so knowing and learning and loving this tool and all of your tools will make you a much better developer. So I look at all these options. This one, I have line numbers. Do you know how often I go to a developer and they don't have line numbers enabled? So what's funny to me about line numbers is line numbers, when you get an error message, it tells you the line number, right? So that right there draws your eye to the code that has the error message, right? If you want to add line numbers, you've got this quick launch right here. You don't even have to go hunting. You just have to type in line numbers on the quick launch, and the options bring you right to where the line numbers are. It's this option right here. Don't have to go hunting for it. So if you've got any option that you care about, like word wrap or anything, font size, just type it in the quick launch, and it'll bring you right to the screen. There's no reason to go hunting for options and things like that, right? So love the tool. And you'll see that I love SSMS. I love Visual Studio. I love SQL Prompt. I love ReSharper. I find it very difficult to code without those things. Just knowing Profiler and extended events and knowing all the different options, knowing keystrokes and shortcuts, all of those will turn you into a great developer. And the next thing, so Brent Ozar, you guys know Brent? So he tweeted something in his pre-con. He did a performance tuning pre-con, and he tweeted something 2 days ago. And he said, in my performance tuning pre-con, I asked who's using column store indexing, and no one raised their hand. That's what, or maybe he said very few people raised their hand, right? And so, no, that is surprising to me. In fact, I didn't tell this story over Twitter, but I'll tell you guys this story. Somebody once paid me. I flew on site, and they said, we have a 7-hour SSIS package and an 8-hour window. And when it fails, we can't run it again, and they've got a day-old data. They don't like that. So can you please make it shorter? And so I looked at all of their fact tables, and I added column story indexing to all of their fact tables in test, not production. And I ran the SSIS, same packages, 45 minutes, right? So 8 hours later, I'm like, I'm done, 45 minutes now. Is that better? Right. All I did was give them indexing that was non-existent before, right? So I'm not a hero for doing that. I just keep track of what releases in SQL. And I use some of the things. So some of the things that I see that people don't typically use are like TriCast. Have you guys seen TriCast? TriCast is great. So let me just show you TriCast real quick. But this is just one example. And I put a list of things that I think you should probably learn, right? So if I create a table, not in, let's create a table in that MyPass Summit DB. Create table T1, call 1, varchar 10, right? Insert into T1, and then that's SQL prompt messing with me, right? But I'll do values. We'll do 1. Excuse me. It's so hard to code in front of all you fine people. Okay, we'll put 3 values in there, right? So, let's make that, let's drop table T1. Oh, here's another example. So drop if exists. Okay. Is it drop table if exists? What is it? Did I mess up? Okay. Okay. So that drop table if exists is new, by the way. And you can refactor all those if information schema view code you have and rip all that out if you want. And just do that. Okay. So then I can say select star from T1, right? And I run that. And there it is. So what happens if I say, no, I want to cast it? I get an error that I'm sure you guys have never gotten because you're much better developers than I am. Excuse me, call 1. And it says conversion failed when converting the varchar value Ike to data type int. And the thing that's terrible about that error is it doesn't give me any context. It doesn't tell me what row, right? So I'm left wondering, what row and column did that come out of? And I'm looking at this query that's like huge, and I can never figure it out. And all you have to do is just switch the cast to a TriCast. And then what happens is it tries to convert. If it can't, you get a null. If it can, it goes forward. But at least you can look at the other columns and the row number and get an idea of where the problem is to go figure it out, right? OK. So I made a list of things that I think you should update your code in, and there's many more than that. So I'm running out of time, and I've got 3 habits left. Habit 11, high performance is not created by accident. So if you want high-performing applications, that's a deliberate decision. If you want secure applications, that's also a deliberate decision. So both of those things are never, I've never seen somebody say, well, I wrote an app, and then lo and behold, 20,000 people used it, and I never had a performance problem, right? You have to decide to be high-performing. You have to decide to be secure and do it. Habit number 12, leave it better than you found it. So I've noticed that great developers, they look at bad code, and it's personally offensive to them. So they dig in, they roll up their sleeves. And I know, like, I look at something, and I'm like, oh, Scott's been here, because this looks pretty clean to me, right? Or, oh, JRaw. JRaw is one of our developers. Oh, JRaw's been here, because I remember this was a mess. And JRaw saw it and was offended and changed it, right? So leave it better than you found it. And in large part, that begins and ends with testing. So they test it. Even if you only test the stored procedure at execution. So even if the stored procedure is 5,000 lines and it's a total mess, and you just say, I'm going to feed in some arguments and run it, that test is way more valuable than no test. Write that test. because then you can change it and at least detect binding errors. You know, it's possible in a stored procedure to delete tables out from under it, right? At least running it will tell you when there's a binding error that before it goes to production, right? Even if you take the 5,000 line stored procedure and you just kind of refactor it just a little bit. So look what I can do. Every time I change back, it like has to change resolution. I apologize for that. So let me see. I've got some code here. What, here? Nope, not that one. So what, here? How about 4? That was 5. Perfect, OK. So this stored procedure is returning 2 result sets. Returning 2 result sets out of a stored procedure means it's not testable. So that's a hard thing to test, right? Well, what I can do is I can highlight this, and I can use this SQL prompt tool called encapsulate as new stored procedure. And this screen comes up. It always takes like a second to come up. But when the screen comes up, I can say, no, this stored procedure for the second result set. Are you going to crash on me? Come on, there we go. We can say that one is called get orders. I type in get orders. I click next. I view the script. It took the highlighted code. It put it in its own procedure. It took the original one, which was 4. Oh, it was, let's see. And it replaced it. So it ripped the code out, and it replaced it with the new call. Now I've got something, at least the internal side is testable. If I wanted to take this other one, I could encapsulate that in a different stored procedure, meaning that my stored procedure has a single purpose now, and make that testable, right? So even if I take large amounts of code, and by the way, it also noticed the dependency. It saw that I was using that parameter, and it created the definition of that parameter in the other procedure, right? So using some of these tools will help you shred these stored procedures into something that's easier to navigate, easier to test, easier to work with, and all of those things mean that it's easier to change. OK. Habit number 13 is a little bit controversial, but it's respond with urgency. That does not mean that every request from a user is urgent. And it doesn't mean you have to have your email open. It just means if somebody emails you, they are expecting a response from you. And base, decent human behavior is to respond to them. So that doesn't mean you have to respond in 5 minutes. It doesn't mean you have to respond in an hour. It just means that they have the expectation that you will respond to them, and you should respond to them. Remember that to your users, you are magic to them. They have a problem, and you fix it, right? They are drowning, and they're begging you for a life preserver. And the life preserver is simply, I hear you, I understand what you're saying, and I will get back to you shortly, right? Great developers respond to their users and their leaders and their teammates. And then remember habit 14, that time is your most valuable commodity. So as you become better and as you provide more value to the organization, every single time you have a personal victory, I would implore you to record it in a personal time tracking device like Excel or Toggle or a Google Doc, so that when the time comes for you to get a raise, you are paid for your value. And that's it, you guys. Thank you very much for your time.